In this gravitational attraction question, we're looking at the force of attraction between you and then the Earth. We're going to then take this one step forward and see if we can find what the gravitational field strength is, and hopefully we'll make some good connections there. So first and foremost, what we know from the question is a couple of things that are given. So let's take the mass of the Earth, and that's approximately 5.97 times 10 to the 24 kilograms. We'll make use of the average mass of a person in North America, which is approximately 80 kilograms. And we'll need to make use of the distance between the center of the Earth and the surface, which is on average, because it does change depending where you are, but on average 6.38 times 10 to the 6. That's in meters. So that's the average radius of the Earth. So if we take our equation Fg equals G m1 m2 over d squared for distance, and let's plug in some of our values. So of course we know our constant for G, 6.67 times 10 to the negative 11. And just to remember, this is in newtons, meters squared per kilogram squared. We'll say the first mass is the mass of the person, 80 kilograms. Second mass is the mass of the Earth, 5.97 times 10 to the 24 kilograms. And our distance from the center of the Earth to the person, 6.38 times 10 to the 6 meters, and that is squared. Putting that into a calculator nets us approximately 783 newtons. So that's the gravitational attraction between an 80 kilogram person and the Earth. We can take this one step forward though, and what if we're asked to find the gravitational field strength? So the gravitational field strength is just the force of attraction per unit mass. So that is the same as acceleration, right? Because we know that acceleration is also equal to your force of attraction divided by your unit mass. So here we can make use of F equals ma. More specifically, A equals Fg over m. So we can see how we're just going to end up modifying kind of our information from above. So if I take 783 newtons and I divide by the mass of the person I'm dealing with, well, we're left with approximately 9.8 newtons per kilogram, which of course gives us our acceleration due to gravity, or we can just say g, which we know is 9.8 meters per second squared. So these values should be very similar, give or take some rounding errors.